In this video, we are going to be calculating the concentration equilibrium for gases in a chemical reaction. So before we start, we need to learn the basics. First, we have to make sure that the given reaction is balanced. Whether or not the reaction is balanced can significantly affect the outcome of your problem solving. Next, we have to eliminate all of the reactants and products that are either in the solid and liquid phases. Remember, we are only dealing with gases in this lesson. Third, we have to write the equilibrium constant expression. Typically, it's in the format the concentration of products all over the concentration of the reactants. Next, and lastly, we have to plug in the given values into the expression. For this lesson, it's going to be written in terms of their molarity. Let's start with a simple problem. Consider the following reaction. Ethene combines with hydrogen gas in a synthesis reaction to form ethane, where the molarity of ethene is 0.235 molarity, hydrogen gas has 0.426 molarity, and ethane has 0.0995 molarity. Calculate the concentration equilibrium of the given reaction. Recall that the first step is to make sure that the given reaction is balanced. Now, what I like to do to balance equations is to place all the elements I have in the middle and write a label that says reactant side on the left and product side on the right. Then I'm going to count the number of atoms that each element has on the reactant side and on the product side. So, on the reactant side, for carbon, we have 2 carbons. Now, on the product side, we have 2 carbons as well. So, because the number of carbons match up, we can say that carbon is already balanced for both sides of the equation. Next, let's count the hydrogen atoms. On the left side, we've got 6 hydrogen atoms, while on the right side, we've also got 6 hydrogen atoms. Because the number of the atoms of the elements match for both sides of the equation, we can say that the reaction is chemically balanced. After making sure the equation is balanced, the next step is to eliminate everything that are in the solid and liquid phases. Remember, we are only dealing with elements and compounds in the gaseous phase for this topic. The next thing we have to do is eliminate all of the products and reactants that are not in the gaseous phase. This means eliminating all of the reactants and products that are in the solid and liquid phases. Recall that for this problem, we are only going to deal with those in the gaseous phase. And because of that, those that are in the solid and liquid phases will not contribute to calculating for the concentration equilibrium. In the case of the problem, it can be said that none of the reactants and products have to be eliminated. This is because everything is in the gaseous phase. And because everything is in the gaseous phase, it will mean that when we calculate for the concentration equilibrium, all of these products and reactants will contribute to it. Now, after eliminating all of the reactants and products that are in the solid and liquid phases, the next thing we have to do is to write the equilibrium expression. The equilibrium expression is typically calculated or written as the products over the reactants, with the x and y shown here representing the coefficients if there are any. Here, in the case of this equation, it will be written as ethane all over the product of ethene and the hydrogen gas. Because there are no coefficients in this equation, we do not have to write any exponents and we only have to simply multiply and divide as usual. Now, we just have to plug in the given values. These values are the ones given at the start of the problem. Because we're dealing with concentration, Remember that the values have to be in terms of their molarity. So we plug in the values in the equation with the molarity of ethane on top and the product of the molarities of ethene and hydrogen gas at the bottom. Plugging in these values will result to an answer of 0.994